Chapter 1.1, Day 2, we're going to take a look at more transformations and translations of parent functions. So let's look at some vocabulary. Transformation. So I think of the movie Transformers and think about, let's say, Bumblebee. So hopefully you know a little bit about Bumblebee and Transformers. Bumblebee is a transformer, right? He is a robot in one moment and then he can transform into a car. And so notice that when he does that, he's changing his size and his shape. And maybe he's also changing where he's standing and things like that. So transformation. So transformation changes the size, shape, and position or orientation of a graph. Now translation, so think about the word translation. Think about words, right? Different languages. So for example, table in one language is, still a table in another language. So for example, we say table in English and then in Spanish it could be mesa. And so it's still a table, right? I could take that table and I could also move the table maybe across the room somewhere, and it's still a table. So translation is still a transformation, but it's a specific type. It shifts a graph horizontally and or vertically. So like horizontal, it's going to go left or right. Vertically, it's going to go up or down. But notice that it does not change the size, shape, or orientation. Okay, so just some vocabulary. So let's look at example 2, graphing and describing transformations. Now in this video, I'm just going to focus only on absolute value functions. So we're going to graph g of x equals absolute value of x minus 4 and its parent function. Then describe the transformation. So we have the parent function is f of x equals absolute value of x. And so let's graph it here. So the parent function starts at 0, 0. And then if we plug in 1 again, it's 1. If we plug in -1, it's a -1. So you need to show like a minimum of 3 points and maybe even 5 points if it fits on the graph. Whatever will fit would be fabulous. So here is f of x, and I labeled it. This is my f of x. Now, g of x equals -4. So this -4, how is it going to move? Now, if you don't remember how to do transformation, let's just do this algebraically first. So let's plug in 0. 0 is always a nice number to plug in. If we plugged in 0, we're going to get 0 minus 4, right? Absolute value of 0 is just 4, so minus 4. So instead of at 0, we're going to be at minus 4. If we plug in a positive 1, 1 minus 4 is just 1 minus 4, which is -3. So at 1, we're at -3. And then maybe you see the pattern. If I plugged in a -1, so absolute value of -1 is still a +1, and that's a -3, so it's just here. So what's happening here is that every single point, this -4 tells us that every single point on the parent function is moving down 4 units. So that's our transformation. It went down 4 units. Okay, and then we can finish graphing it. So now let's talk about reflection. A reflection is a transformation that flips a graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line of reflection. And so we'll see that in this next example. So we're going to graph and describe reflections. We're going to graph p of x equals negative absolute value of x and its parent function, then describe the transformation. Now let's just graph absolute value of x. Let's plug in some numbers here. So if we plug in 0 here, we're just going to get 0. So we're plugging it into here. If we plug in +1 to here, it's going to be a +1. Plug in +2, it's a 2. If we plug in -1, that's going to be a +1, and -2 is still a +2, right? So this is our parent function. And so it's going to be here. And we've done a couple of these. Can you tell I want you to be really comfortable with graphing absolute value? And so here's a graph. And I do like to see these clear points so I know what the graph really looks like there. And it should be pointed. Now let's look at graphing y equals negative absolute value of x. So if we plug in 0, we're still going to get 0, right? You plug in 0 here, you'll still get 0. Negative absolute value of 0 is still 0. Now if we plug in positive 1, so we're going to take the absolute value first, and so when we do that, we're going to end up with a negative 1. Then we plug in a positive 2 inside, right? We're plugging it into this function here. We would get a negative 2. So let's do that. So 0 at positive 1, we're at negative 1. At positive 2, we're at negative 2. And then what do you think is going to happen on the other side? So if we had a negative 1 here, that's going to still be a negative 1. If we plug in a negative 2, that's still going to be a negative 2. So it's flipped over. So here is our p of x. And then I'm going to call this first one our f of x. So it's the parent function f of x and the reflected point. So going back to what it said here, a reflected point is the seen distance from the line of reflection. Our line of reflection in this case is our x-axis. And so if we count how far is like this point from that line of reflection, it's 2 away. And then the reflected point is 2 away on the opposite side. So when you describe the transformation, we can say that it's reflected over the x-axis. Now for now, if you say it's flipped over the x-axis, that's okay. But we do need to say specifically that it's the x-axis because there will be times later on that it could reflect over the y-axis. So if you just say it's reflected or it's flipped, I need a little bit more information. And so you just need to be able to put the whole entire thing reflected over the x-axis or flipped over the x-axis. So let's take a look at these examples. So I want you to try them out. Now hopefully you remember from, the day 5 review we did in Algebra 2 of what some of these things do to the function. Now I want you to describe the transformation, number 1, and then you're going to graph all of the parent functions on here. So I should see 2 graphs, the parent function and then whatever the transformed function is. So try these out. All right, so hopefully you try this out. So on this first example, it just went up 3, so similar to our other example on the left. So it moved up 3, every single point moved up 3. Then we have here, now I know it's negative inside, but what makes it 0 is if you plug in a positive 2. If you plugged in a positive 2 here, then it would be 0. So this is actually a right 2. So inside is always opposite. If you see a negative, it's right. If you see a positive, it's left. And so here is the transformed function here. It's right 2. And of course, it's good to label it. This is h of x. You can tell by by colors, but it is good to label with the function name. And then this one here. So on number 4, this one is up 4, so we see that. And then we would read it from left to right. Always read it from left to right. So first we see that it's reflected over the x-axis. And then so we know that it flips upside down. So if we wanted to, you could always graph that first, right? So reflected over the x-axis, I could do that one shift. So reflected down. And then it moves up 4, and so that is the green. So the final function that we would have is this one here. We were first reflected the pink, and it looks like this, and then everything moved up 4 units. So if you need to, you could always do that, and some of you may be able to go directly to here. And as we go through the year, we'll do a lot of transformations all year. You'll get more comfortable in transforming some parent functions.